there, welcome to another college math video. We're going to continue our journey with geometry today, and we're going to start to look at perimeter and area for two-dimensional shapes. So our objectives for this video: review vocab for polygons. Remember, we discussed those in previous videos. Polygon, the general term for any closed three or more sided shape. We're going to find the area and perimeter of specific types of polygons, area and circumference of circles. We'll use the Pythagorean theorem and then use all of that stuff ultimately to find the areas of shaded figures. So our set of notes here, we have the definition for perimeter, which is the sum of the lengths of sides of a two-dimensional figure. This is the distance around. These are general. We will have formulas coming up in a couple of slides. So with perimeter, you can imagine it's a picture that you've drawn. Perimeter is essentially the line that your pen or pencil takes. How much did it take? I like to also imagine that you can measure it with string. So if you're not sure, and this is coming into play kind of on the back end, what the units should look like. If you can measure the item or the thing that you're talking about with string, you could take string and put it on the outside of something, then you would be talking about a regular unit. So I'm going to put example units. And this will feel silly until we get to what the area units will look like. It would be regular units. So feet, inches, yards, miles, anything like that. They'll just be regular units, just how you would imagine measuring something in feet. Our other note, the other thing we're looking at on these figures is the area, and this is a region within the boundaries of the figure. So we will see lots of shapes, but it's how much does it take to coat the object. You can imagine if you were trying to paint something, if the question said, or you could imagine whatever it was talking about instead could be replaced with paint. Actually, I'm not going to say paint. Let's go with sticky notes. Because paint might be a little tricky in terms of paint. Sometimes you can have a can of paint. It's kind of a three-dimensional thing. I don't want to think of it that way. So imagine you wanted to cover an object with sticky notes. We could look at this circle and decide how many different sticky notes. Some would be whole, some would get cut up, and that's okay. Their formulas will sometimes lead to decimals, maybe a rounded answer here and there. But it would still take sticky notes to coat an object. And the example of some of the units that you might see would be feet squared, inches squared, yards squared, miles squared, anything that would have the little exponent of 2 next to it, or you could just write the word squared, feet squared. This is a little tricky because sometimes people will mistake this to believe that it means an additional computation. It's just a unit of measurement. So feet is one thing. It's a distance that looks something like this. Square feet is a foot by a foot. How many of those? Imagine a sticky note that was 1 foot by 1 foot. How many of those would it take to coat the object? That's feet squared. Inches squared is an inch by inch. How many of these little squares would it take to coat this object? So not a computation, just a unit of measure. So you'll know when you're coming to the end in the question, because in the questions you'll always be writing some sort of units. If it doesn't say anything in particular, it doesn't say feet, inches, yards, then you'll just write the word units if it's perimeter, and units squared if it's an area. So that'll be the last thing you assess. If you're not sure which unit to use, just imagine the thing that I was figuring out. Could I have measured it with string? If so, then you would use units. Could I have measured it with sticky notes, coating an object in sticky notes? Then it would be units squared. All right, so let's start to see the formulas. We have quite a few. These are perimeter and area formulas. So the first shape we'll have is a triangle. The perimeter formula is just to add up all 3 sides. The 3 sides don't necessarily have to have anything in common, so there's no way to make it any simpler than to just add the 3 sides. And then the area formula is 1/2 base times height. So let's draw the picture and identify all those different pieces. Triangles can look lots of different ways. As long as it's 3 pieces coming together to create a closed figure, you have a triangle. Side 1, side 2, side 3. This piece won't necessarily always be there if the triangle, if this kind of left side was cut off and this is what the triangle looked like, your S1 would be on this side here. But the height has to be given to you in some way, shape, or form. And then the bottom can be referred to as B, the base, or S3. The S is 1, 2, and 3. It doesn't really matter how you order them, because for perimeter, you're just adding up all 3 of them. If you're using area, you will have to identify a base, and then the height will come from that base. Okay, second shape, square. We know what that one looks like. We talked in detail about what it takes to be a square, and you already know. It's a bunch of right angles coming together and all 4 sides are the same. So the perimeter formula is 4 times S because each side is the same. You could alternatively just add up all 4 sides. That would also work. And then the area formula is multiplying S times S, so S squared, because they're the same. You fill in by multiplying essentially a length times width, but they're the same measurement. You can use length times width with squares. You can use the rectangle formula with a square. It'll ultimately work out. But if you have a square, then you can specifically use these. Okay, for a rectangle, we know what this looks like. We typically identify the sides as L and W in a rectangle. The perimeter formula is 2 times the length, because there are 2 of them, and 2 times the width. Add them together, you've got it. Or alternatively, just add up all 4 sides. And then area, where we're shading in, is length times width. And you see, it would be shaded in. We'd be coating it with sticky notes. We'd see how many sticky notes it took to cover the object. All right, that's 3 of them. The next 3, parallelogram. We saw what this one looked like in the last video. Remember that the top and bottom are equal to each other. So you really only need to know one. We'll call the bottom base, so the top would also be base. And then the only other thing you need to know, similar to the triangle, it has to be coming from the base to the top directly, meaning it creates a right angle here, is the height. If you know that, then you can figure out everything. Perimeter, 2 times base, because there's a top and a bottom, plus 2 times width. So for perimeter, you would need to know these outside numbers. Again, 2 times W, because there's 2 of them. And then the area is base times height. And you might be wondering, why is it as simple as kind of the rectangle-looking formula? Because if you can imagine this part, this left side, this little triangle being cut off and flipped over and filled in here, we essentially would have a rectangle. So the formula is relatively easy to use. All right, the next one we have is a trapezoid. Remember, in a trapezoid, the only thing really special is that the top and bottom are parallel. Nothing else necessarily is equal, which is why the perimeter formula is a messy one. We have base 1 and base 2, which are top and bottom. Doesn't matter how you label them. Side 1 and side 2, so S1, S2. Again, the order that you label them doesn't necessarily matter. Perimeter, add up all 4 sides. There's no cleaner way to write that formula. And then area, how many sticky notes would it take to cover this object? 1/2 times the height. So again, we'll need to have this piece of information from the base, something going straight up, creating a right angle. We'll need that one, and then the top and bottom, and that'll give us the area. This kind of takes into consideration the same thing here. There's lots of ways to chop this up and make it a nicer looking shape if you wanted to. That's essentially what the formula does. You're definitely not doing anything like that. All right, and then the last one is a circle. I'll draw this shape here. For a circle, the perimeter is called circumference. Let's add that here. It's the same idea, it just has a different name here. And the formula is 2 pi r. Pi is just a button on your calculator. It's a number. It's an irrational number, so a decimal that goes on forever. In any online homework system, it will tell you whether you should type pi in your calculator or you should use the approximation. It'll tell you, but pi is approximately 3.14. So just look out for that on the online homework system. When it comes to any work that you're doing for me that might be written, just look for directions on which one to use. And if I don't specify, then it's your choice. All right, so the only other thing we would need to know is r, which is the radius. It's the distance from the center all the way to the outside of the circle. And this piece of information can come from anywhere in the circle because from the center to the outside is the same distance all the way around. So that's for your circumference. And then if you want the area, what it would take to shade in this shape, pi and then r squared. Again, pi, either use the button on the calculator or use 3.4, whatever the online homework system calls for. And then r squared, again, you would need to know radius, which is distance from the center to any of the edges. One more piece of information here that might occur. So if you're asked these questions, you might be given the radius. You might also be given the diameter, which is the distance all the way across the circle through the center. If this is the case, it's a very simple relationship. 2 times the radius is equal to the diameter, or the radius is equal to the diameter cut in half. Whatever this number is cut in half, that's your radius. Both formulas call for radius, so if you start with diameter, you're going to have to go to radius. Only kind of special thing that can happen there. All right, so here are these formulas. We've got just one more, the Pythagorean theorem. This one isn't necessarily perimeter area. This is just to be able to find sides of a triangle. Pythagorean theorem only works when we have a right triangle. Must be a right triangle. And you'll know that it's a right triangle when you see the little box in the corner somewhere in the picture. Or maybe it's noted for you. So let's say this is the right triangle that we have. We'll label the sides A, B, and C. And I'm sure some of you are already saying you remember this formula. You're probably ahead of me in listing it already. A squared plus B squared equals C squared. Now, in the picture, A and B, I've written A on the left short side and then B on the bottom short side. The only thing that's really important is that C is the longest side. It's the one across from the right angle. So let's just add that as a note. C is the longest side. The other two can be flip-flopped. If we had listed them the opposite way, the formula might read B squared plus A squared. It's the same thing. We would still square this number and then add it together to go forward. Okay, so let's do a little practice using these formulas. First example, we're looking for the perimeter and area of this figure. Let's change the color here. So the problem given doesn't have the little square in there. I'm adding it in. Let's go back. Okay, so how can we find perimeter and area? We have a triangle, so let's list the formulas. Perimeter is side 1 plus side 2 plus side 3. We can't do that yet because we don't have the third side. And then the area is 1/2 base times height. We have a base, but we don't have a height. So how can we find this third missing side in the triangle? Well, we can use Pythagorean theorem. We have a right triangle, so we can find the third side using Pythagorean theorem. Okay, so A squared plus B squared equals C squared. Let's plug in the most important piece, which is the C. Which is the C? Looking at the picture, the longest side is the 12 squared, A squared plus 9 squared. Okay, a little bit of algebra in this class. Here's what we have to solve. 9 squared, you can do in the calculator or in your head, it's up to you, is 81. 12 squared is 144. Subtract 81. A squared equals, we did 63. And then the last step, we want just A, so we'll take the square root of A. A equals, you can do it on the calculator. Now, some of you are wondering, could you simplify this and use the simplified answer? Yeah, that's fine. For our purposes, I'm going to go with the decimal approximation, and I'll just go one decimal place. So we get 7.93, so I'll round it to 7.9. I don't imagine that you will have a problem where you'll get a decimal approximation. You should get really nice, clean numbers. But just for the video, this was the one I could find, so this is what we're going to use in here. Okay, so our A value is 7.9. 0.9. Okay, now we ultimately needed that to be able to find perimeter and area. So now perimeter, we have all three sides, 7.9 plus 12 plus 9 gives us 28.9. And we don't have any sort of unit listed, like inches, feet, anything like that, so we'll just put units. And perimeter is always a standard unit, just regular units. Then for area, 1/2 the base, which is 9, times the height, which is 7.9. You can type all of that in the calculator. And we get 35.55. That's exactly what the calculator gave, so I'm going to go with that one. If you rounded to 0.6, that's okay. Just watch what an online homework system asks for you to round if it's necessary. And this is an area. Area is always units squared. So feet squared, inches squared, since we don't have anything in particular, we'll just go with units squared because we're talking about how many little squares it would take to fill in this object. And it would take some sort of decimal because we have to cut pieces and kind of manipulate them a little bit. All right, so there's one version of using these formulas. We're not going to see a problem that uses every single one of the formulas, but the formulas are not anything you'll ever have to have memorized for any sort of activity or test you might take. So just keep that in mind. You would be given the formulas. You just need to be able to use them. Okay, let's find the area of the shading. So I need to fill in a little bit of information on this problem. Let's say this is what we know. Ooh, we need this color. And I'll go ahead and fill in that these are all right angles. So we have a circle. There's a square inside, and we're looking ultimately for the yellow shaded area. If you're having difficulty seeing, it's what's outside here, here, and here. And the information we know is from the center of the circle out, and then we know a little bit of information about the square. So ultimately, how do you think we could think big picture, not in the numbers yet, what would we do to figure out the shading? So first we have a circle, and it's essentially as if we have a square of shading removed from it. So if we can find those things, then we should be good to go. If we can find the area of the circle and then subtract out the area of the square, what we'll have left are these little pieces on the outside that are shaded. So if you need to reference back, let's go ahead and get those formulas. Area of a circle is pi r squared. And then area of a squared is side length squared. All right, so we're going to use pi. If you have the calculator in front of you, you can type pi, and then we'll have a decimal approximation in the end. We have pi. What's our radius? We are given radius from the center out is 6. Let's get this first. So 6 to the second power. Remember, order of operations, grouping symbols, nothing inside here. Exponents, 6 squared is 36 times pi. I'm going to hold on to that for now. And then our square, we know that this side is 8. 8 squared is 64. Now note, if an online system asked for an exact answer, this is what you would give. Because once you type pi into a calculator or type 3.4 into a calculator, you have an approximation then. So if anything asks for an exact answer, this is what you give. If we're looking for a decimal approximation, then we can type it in the calculator. So 36 pi is 113. I'll just go to 2 decimal places, 0.36. 0.097. So ultimately 0.10, still minus 64. Then subtract it out, 49.10. So if we wanted a decimal approximation, this is what it would look like. If we want an exact answer, 36 pi minus 64. Oh, but one last thing is missing from both answers. It's the units. So in each case, either one, we still need to write our units in. We don't have inches, feet, anything like that, so we'll just write the word units. But we're talking about area here. So these are both units squared. Units squared. Typically in an online homework system, it will write something like this, the unit that you're looking for, it'll list it in there and you will simply type in the number or this exact 36 pi minus 64. But on anything that's going to be written, that is something I'm looking for, is for you to list what type of units they are. If they're regular, if they're squared, if they're cubed, that'll come next. All right, so let's go to a little practice then. We have two practice problems. We're doing essentially the same thing. Perimeter and area, you've got the shape given, and then just the area of the shading that's listed here. I need to give you one piece of information to be able to do that. And it's from the center to the outside. It's 3. Okay, so go ahead, pause the video, attempt to work these problems through, and then we'll see if we're on the same page when you're done. Okay, welcome back. Hopefully we've gone through practice. That's a part of the important part of the process. Yep, that's good. So let's start with the first one. For this one, we very specifically have a trapezoid. The word escaping my brain. We're looking for perimeter and area, so I'm going to list the formula first. For a trapezoid, it's pretty straightforward. Base 1 plus base 2 plus side 1 plus side 2. We have all 4 of those things, so it's just a matter of plugging in the numbers. Well, let's write them in the same order. 14 plus 18 plus 10 plus 9 gives us 51. And these are centimeters, regular centimeters since it's perimeter. It would take 51 centimeters of string to go around the outside of this shape. If you didn't write centimeters on anything that would have been written and turned in, you'd lose a point. Just having 51 is not the full correct answer. Okay, then the area. The formula is 1/2 height times base 1 plus base 2. It looks like we have all of that information. The height in the picture from top to bottom here is 8 centimeters. And then base 1 and base 2, it doesn't really matter what order you plug them in here, so they're just going to get added together. Follow order of operations, add them together, we get 32. Then multiply 1/2 times 8 times 32. You can do all of that at the same time in the calculator. We get 128. And then these are centimeters squared. Since we're talking about area, that would take 128 little centimeters squared of paper to coat this object. Lots of little sticky notes coating it. Okay. All right, good for that one. The second problem, just looking for area of the shading. Now, remember we talked about radius and diameter. If you know that this distance is 3, then you also know that this distance is 3. And all of these circles are the same. So if you know that each of those is 3, then this is 3 and this is 3, which means ultimately your width for this rectangle that contains all of those circles, 3, 6, 9, 12, is 12. You can do the same thing going the other way. All the circles, it's the same from the center all the way out. Another 3, 3, 3, 3, 3, 3, 3, 6, 9, 12, 15, 18. And so we have the same type of feeling question as the example. We'll take area of the rectangle and then we will subtract out all the missing pieces, which are the circles. So our general plan is going to be area of rectangle minus 6 times area of the circle. 6 times because there are 6 of them. All right, so area of the rectangle is simply length times width, which we've just figured out is 12 times 18, which is 216. And then minus 6 times area of the circle is pi r squared. Now we only need to find one. Pi 3 squared. So 9 pi. So I'll keep working over here. We have 216 minus 54 pi. And again, this is where you would pause if we were looking for an exact answer. The only thing missing would be units. There's nothing in particular listed, inches, feet, so we'll just write units. And these are square units since the question is area. Or if we wanted a decimal approximation, you can type all of that in the calculator at once, or you can use 3.14. If I type in pi, I'll have 216 minus 54 pi. We get 46 point, I'll go 2 decimal places, units squared. Okay. 0.35. You might be wondering, how would you ever decide where to round the decimal? I promise you an online homework system is going to be specific if that's what it wants you to do. And on anything that you would turn into me, if I'm not specific, then it's totally up to you where you round. All right, and then this is our approximation. But the general idea here is the same, and you'll see lots of problems like this. You'll even get this feel in the next video. We have the entire shape, and then there's something missing. So we just find it first as if the whole shape was there. What are all the little missing pieces? And then subtract them out. Common question I get at this point typically is, why did we multiply by 6 at this point? Remember, there are 6 circles. So we found the area of one circle multiplied by 6 since there are 6 of them. You could alternatively do 9 pi plus 9 pi plus 9 pi over and over. Repeated addition is multiplication, so it's the same thing. And then you've got whichever version of the answer it would be looking for. Okay, so this video was a look at the 2-dimensional shapes and finding specifically area and perimeter. As we move forward, we'll start to get into the 3-dimensional shapes. I'll see you soon for another video.